Good morning, everyone. How are you going? How are things at next for you guys? First of all, thank you for coming for this great session. And before we go into deep dive into this topic today, I have a couple of questions for you guys. How many of you struggle or need more guidance when you pick a database service for your new application or modernizing or moving your databases? Show of hands. Okay, cool, nice. I can think of it. Another question is, how many of you would like to know how our Google Cloud customers are thinking about or going about choosing database for their agentic applications? Checked. So you are in the right session. We are going to answer these two questions in this session today. How to go about choosing a database for your workload, and also how you're going to see the customer doing it. My name is Kiran Shenoy. I'm Senior Product Manager for Databases, but I'm not the only one here today. I have two great presenters with me. Starting with global commerce leader, pioneering the enterprise graph intelligence and agentic AI platform at scale. I would like to welcome Deepika Khera, Senior Director at AI at PayPal. And next, imagine building an AI-driven platform at massive global operations. Someone who crushes every day that challenge. Please welcome Mukund Gopalan, Chief Data Officer at Ingram Micro. So stay till the end, and you will see. And if you have any question at the end, we'll take. We are all here. Whatever content we walk through, and we are able to take any question. So agenda, only 3. Keep it simple. Current database trends in the AI world. You are here at Next. You are talking. You must have hearing everything about agentic era. Hearing about data agents, heard about agentic data cloud here. But where is database heading? Where is the trends happening there? And how it can help you to build your next innovative application. And for that, you need to choose database. So I'm going to walk into that layer there, how you go about how we see our customers are choosing, existing customers, and how you, if you want to go for a new application or migrate, how you should be going about doing that. And last but not least, going through the customer stories and what are the key takeaways at the end for you guys. So current trend. So we are witnessing a fundamental once-in-a-generation shift here, and we all know that. The modern landscape modern database landscape is moving from static storage to enabling agentic action. But this massive shift is driving 3 key requirements for any modern database. Pick any one of them. First, database must deliver infused AI across all workflow. And that is required because you have to turn your raw data into immediate intelligent action. Second, they need to provide real-time intelligence. It's not a requirement anymore. It is a necessity for all businesses. Third, it has to be open and work across different data layers seamlessly. And that brings us to another point. And you might be hearing over last 2 days. The major shift in this world is happening where the traditional wall between OLAP and OLTP is crumbling. We can no longer afford to separate system that runs the business from the system that understands the business. The two must converge. And that's why you must have heard of the agentic data cloud we launched this year at Next. And finally, natural language is become a language of choice for everyone, for developers, when I say the builders, the operators, and the generic users. So you can converse in natural language no matter which database you pick. And for that, your database should be vector-enabled. Internet. So you ground your data in your AI models. This is critical to achieve high accuracy and, most importantly, building end-user trust in those applications. And that leads to the rise of agentic tech. You have your data over the decades in customer, as a customer, you have collected so much data there, but now you have to create new interfaces for those information. How you make sure those information are digested by your customers, your end users, and you think about it. So there are 4 categories I mentioned there, but a lot more are there. Personalized feeds, and you see that in day-to-day life. Today, technology is anticipating customer needs with personalized feeds and literally which understands your need before even you click. Based on your history, based on your profile, it gives you those suggestions. And also, we have seen a lot of agentic browsers. Browsers are not just about now reading and you go there and in the past you just browse it. It's about doing the action, what you do next, transforming into proactive tools to execute complex tasks for you. Also, we have AI assistants or agents, no longer like a search bar. It's moving beyond just using the raw data and true guide to offer the real active contextual counsel for you guys. The ultimate takeaway is this: the future of database moving from passive library or storage into indispensable, proactive decision-making partner for you guys. So think about it when you look at your application build. And how are our customers responding? I'm giving 3 examples. We hear from existing customers on the stage here. But I would like to call these 3, and this is very resonate. These are the real one example where we have Make My Trip, which is an online portal. They have built agentic travel plan, a personalized real-time recommendation. It's built on Spanner, multimodal database. Then we have Target, you must have heard. It's hyper-personalized, best for you feeds, so customer can go there, do hybrid search on their what they're looking for, and it can respond. It will also respond you on your behavior. Suzano is a Brazilian company. It has been internal agent converting natural language to SQL, reducing the query time by 90% for their 50K employees. So you can see the agents are not just for external applications, but internally, organizations are improving their internal processes, helping their employees to make sure they use those AI for their productivity. The goal is simple. There's one goal: to give back the users the time so they can do more. Okay, now let's come to the main topic about choosing database. Right database for your use case. Before we go there, I just want to run through our 7 different databases, and that's why I'll walk through. We have a database for every workload you have. We believe modern data platform must be open at its core. That's a simple idea. And that's why if you see these 4 categories at the top, starting with in-memory, we have memory store, which is a caching layer or caching database. You can put in front of any application for sub-microsecond latency. You can run Redis, Valkey, and Memcache. If you have Postgres and MySQL, we have Cloud SQL. But don't leave your Oracle and SQL Server behind. We have Oracle database at Google Cloud. You can bring your Oracle data, or SQL Server to Cloud SQL for SQL Server. If you need a Postgres, with high-performance Postgres, or you have a hybrid workload where it has to be read-intensive along with the writes, or you want to use advanced AI with AI functions and different capabilities we have developed, or you want to run Postgres on-prem, AlloyDB is the solution for you. It can run AlloyDB in cloud and AlloyDB Omni in anywhere. It can run on-prem, it can run any cloud, or it can run in any environment you need. Spanner is another one. Spanner is globally available, horizontal scalable database, multimodal. Again, you must have heard that this year at Next, we also launched Spanner Omni. So you can take Spanner where you are. So we are taking these databases where the data lives. So you can run anywhere we want. Bigtable is our key value store database. Gives you high throughput. The best part is it is Hedge-based interface compatible, Cassandra compatible. So if you're running those databases on-prem or wherever, you can bring them to Bigtable. Firestore is a document database. So if you're running, if you want MongoDB compatibility, File storage is a solution for you, so you can bring those databases. So you can see we have a database for all this, all your workloads. So let's take one by one. Take an example where you're modernizing your open source relation workloads. When I say open source, example is MySQL, Postgres, and you're running in self-managed mode, wherever they are. What is the solution we got? Starting with Cloud SQL Enterprise Plus. It is fully managed, enterprise-ready, developer-friendly, full compatibility with MySQL and PostgreSQL. I've given it four bullets. There are lots more. Cloud SQL is beaming with all the capabilities there. 4.9 availabilities gives you. It has data cache for very high read acceleration, optimized writes, managed connection pooling if you want to control, manage the application performance as the application scales. It has a data protection, strong data protection with extended backups, which goes multi-region, and also a PITR up to 35 days. That's for MySQL and Postgres. You might say, I need to have Postgres, even highly performant Postgres. That's where the AlloyDB comes into picture. So we have AlloyDB for demanding high headstrap workloads, where you have a high reads and high writes happening at the same time. So it gives you 4x transactional throughput compared to standard Postgres you have. 100x analytical reads happening there, queries. The best part is agentic AI enabled. It has all the features, all the latest features for that. So it has 4x vector search and 10x high throughput there. And it does all this using less memory, 3x to 4x. So it gives you more with less. Again, I mentioned there, AlloyDB, if you want to run in Postgres, in on-prem, you can do that. But what is the solution if you have sharded MySQL? Our customers are going for that, Spanner. If you have sharded MySQL, you are hitting the wall of scale, requiring global, all-in-one, multimodal database, especially in case of sharded MySQL, then you need to look at Spanner. And that's what our customers are doing there. We are not just pointing you to Spanner. We have created migration tool. We have created a migration tool to help you get from MySQL to Spanner, because it's a big journey. And we are offering that support there. The Spanner provides that unlimited read-write scale, multimodal support, as I mentioned there, 5.9 availability. It's always on. So if you're running, you need that capability with zero maintenance downtime, Spanner is the solution. So this is focused about MySQL and Postgres. I don't want to leave Oracle databases behind, and nobody wants to leave Oracle database behind. If you have Oracle database running, looking after your critical applications, and you want to bring that to the Google Cloud to join with, or bring it to connect with BigQuery, connect with Gemini Enterprises, is there. And I have to walk through these 4 categories, very important, because there are nuances I want to call out, very important. If you have Oracle running Exadata or RAC on-prem, we have Oracle database at Google Cloud. In dedicated environment, you can run it. So you need the full power of those applications which have been, grown over the years, and you need that thing, dedicated Exadata box, and you can, that you can run in our Google Cloud Closer, and you can pump that data to Gemini Enterprise and get more value, or connect with BigQuery, and you can do whatever you want, and you can bring multiple applications on top of that. If you want to have a scalable rack, or you want to start small on Exadata, a chunk of it, as a tenant, then you exascale on Oracle Database Google Cloud. So you're starting small and you ramp it up. If you want a fully managed Oracle database, we have Oracle database, or you can run autonomous database on Google Cloud. But you might say, I don't have RAC, I don't have Exadata, I don't want to fully manage, I just need a place to run Oracle database. Fine. You can bring it to GCE, GKE, GCVE. You have that option there. And the 5th option is, you might say, hey, I want to modernize. I want to take it to the open source. I want to use the Google Cloud services. We have that option too. You have AlloyDB as a Postgres service. So we have customers adopting there, or customers are going to Spanner. So You have an opportunity to bring the database closer to Google Cloud or look at option as modernizing them. So we spoke about MySQL, we spoke about Postgres, we spoke about sharded MySQL, and we spoke about the Oracle. Now look at the NoSQL workloads. And you can see the X and Y axis here. There are two categories you can see here. One is what is the consistency needs. You need eventual consistency or strong consistency. Or you need, what is your data model complexity? Is it a simple key value or you need multimodal? And this is based on what we see our customers are doing. That's why we're sharing, and that's what advice is for you guys. If you have eventual consistency need, simple key value, Bigtable is a great solution. If you have HBase, Cassandra, DynamoDB, Aerospike, or ScalaDB, we have seen customer moving to Bigtable. It gives seamless HBase API, unlimited scaling, finite availability, and you might have heard at this next, we also launched something called in-memory layer, in-memory tier. That reduces, give under 2 millisecond read-write, even faster. So you don't need a caching layer in front of the Bigtable. It's all in-base, included as a part of Bigtable Enterprise Plus. But if you want to say, I have Cassandra, but now my business needs have changed. I want to go for strong consistency, and I need to add multimodal capability to that. That's come to Spanner. So we have seen customer going at Spanner because you have acidic requirement, global consistency requirement there, relational foundation is there with that, and it's always on. So key takeaways here, the Bigtable is for raw speed and scale, Spanner to upgrade your NoSQL to global transactional integrity. Okay, what's next? What about the document store and caching store? So if you have sources like MongoDB or Amazon DocumentDB there, and you want to eliminate the operational drag you get at the moment because you're self-managing it, you want to go for serverless option there, modernizing so you can focus on your business. So Firestore is an option for you as a target. It has MongoDB compatibility. Again, because serverless is pay-as-you-go model, its range is elastic scale as your workload increases or decreases. Finite availability there. And best thing of Firestore, you might, if you attended the session yesterday, we spoke about wipe coding. It has agentic full stack development. So developer love that. So we have embedded or integrated Firestore with AI Studio now. So you can ramp up or create application in no time and try to do the prototyping before we go into production. Then look at the Redis and Amazon Elasticache. If you want to do in-memory thing, or you want to cut down the cost and latency, and you want to have high performance scale, we look at memory store. Memory store have option of, as I mentioned, key value, Redis, and cluster. If you have like a single node or clusters, you can go for Redis cluster there. Again, fully managed, sub-millisecond latency there. Again, 4.9 availability is available there. So this is not just about migrating from source to target. It's a strategic upgrade as we see to ensure your document and the caching layer are built for that high performance and zero operational complexity. You might say, Kiran, this is great. Like, you told us everything. This is good in theory, but I still am finding hard. When I go and sit on my whiteboard, I draw things. There are so many services, right? We have 7 services. Is there an additional help you can give? A guide partner, which I can invoke anytime and talk to that person or agent? This is what we have done for you guys. So we are not giving theory or documentation or slides or anything. You have an agent available for you 24/7, anytime, to talk to, give your requirements. So you key in your requirements. We call it database onboarding agent. It's launched in preview at Next now. So you state your application needs, expected behavior, performance needs, scaling needs in natural language. And it's going to respond. It's going to take those inputs, going to iterate. If it's not happy, it's going to ask you more questions. It's not going to throw a solution to you. It's going to make sure you are knowing what you're looking for, and report you a suitable solution for your workloads out of those 7 databases I mentioned there. So you're going to get a tailor-made recommendation for your use case, but it's not just that much. It also tells you how to get started. What does it mean? It'll give you a G-Cloud command, a Terraform script there, so even further. So it's not going to tell you what database to use. So this is something many of our customers were asking, and we have solved for that. Let's take a quick demo of this. Hopefully it works. OK. Let me pause there. So how you access it? Go to Google Cloud Console. Make sure your Gemini Cloud Assist is enabled, and start. There's nothing config. There is no setup there. Make sure as long as your Gemini Cloud Assist is enabled, you can start asking or having conversation with onboarding agent. As simple as that. So here, I went to that. I've entered my requirements. I'm saying, hey, I want to build an enterprise e-commerce app, which has to be highly available, Postgres compatible, is going to have, I need to store vector embeddings because it has to have AI capabilities. It is also has to be fully managed, high performance, and minimum maintenance downtime. What should I do? Where should I look at? So it's going to think, it's going to go through your requirements, make a sense of it. And going to come up with the option. And also tells you why. For example, now it picked AlloyDB for that e-commerce app. And we're also going to tell you how to set it up. You can see there are 2 categories. First, solution for your use case. You entered in natural language. Why AlloyDB is a solution for you. It gives you the features. And then it asks you, hey, do you need help with setting up? Do you want a G-Cloud command? In this example, I say, yes, give me some G-Cloud command for that. Show me how to create clusters, instant, and all those details, or enable the vector capability. Okay, let me see. Oops, sorry, is it coming? Oh, see, demos are always like this. Sorry. Working. OK. Let's go through quickly again. So it's showing you the database it has picked. It'll tell you about the G-Cloud command, what to use. And this is based on your query. It is different every time. Based on what you've asked, it'll give you those response. And you look through the details, and you said, yes, give me the commands here. See here now you can see it'll give a piece of information around how to go about creating those cluster, create primary instant, and also add the vector column support there. We would really like to make sure you try it out. Is in private, is in public preview now. Give it a try. And before, and these are the few. This is what I show you the summary of databases, source and target where you should be heading on. And these are the targets one. As I mentioned there, we have a solution for each of your source databases, either homogeneous migration or heterogeneous migration. This is something I mentioned earlier on. If you have Sybase, we're looking at Oracle, looking at SQL Server, Aerospike, ScalaDB, or even GraphDB is coming to Spanner Graph there. in the interest of time, I would like to call upon Deepika, Khera. So let's focus on the customer stories, how those journeys have gone for them when they went about choosing database for their application, some real life use case. With that, over to Deepika to go through the enterprise graph intelligence solution.
Thank you.
Thank you.
Thank you so much, Kiran. Hi, this is Deepika from PayPal. So as we move towards an AI-first agentic future for commerce, right, it becomes critical to enable trusted, unified intelligence in real time so that our agents, our products can reason and act instantly with the shared context that is given to them. Now, modernizing our platforms and building these core capabilities is central to our strategy at PayPal. And Unified Enterprise Customer Platform is one such foundational layer. And today, I'll take you through how we built this unified view of customer using a real-time graph-native architecture, running traversal and connected component algorithm at scale over billions of entities. So customer is PayPal's most important entity, right? And we want to have the best-in-class experiences for our customers, be it merchants or consumers. But PayPal isn't just one product. It's an ecosystem. PayPal, Zoom, Venmo, Hyperwallet, Honey, Braintree, each grew up with its own identity systems. And a single person may have a PayPal account, a Venmo handle, and a Honey profile all at the same time. Now, to power ads and personalization for those best experiences and seamless commerce, we must move from these fragmented entities into this unified view of customer. And this requires a system that can evolve really quickly, resolve entities really quickly, traverse relationships, and provide that unified view. And then that helps us serve context-driven experiences, that helps us to detect unforeseen risks and attacks that we may have, and optimize our own operational spending on ads and such. So I'll quickly introduce the Unified Enterprise Customer Platform. At core, it has 5 tenets. It's unified, so it's one connected view, no silos. It's trustworthy, it's scalable, so we can extend it to the increasing workloads that we have and also the new use cases. It's explainable. Now, with a graph-based architecture, every account linkage that we do carries the reasoning of why these entities are connected. So full explainability that we always want in today's world, right? And it's real time. It can take large-scale identity updates instantly. So let me walk you through how this actually works under the hood. Now, the entity resolution process operates incrementally and is driven by incoming account changes. Source systems across all our products, Venmo, PayPal, as we are creating new accounts, as we are updating addresses, emails, it flows through into the platform. And then is the heart of the platform, right? When we use the power of the graph. It leverages graph query language over spanner graph at every step of the ER process. Let's understand this a little bit more. So the first piece is normalization. This is just a pre-processing step. We clean up, we standardize phone numbers to be international, having the international codes. The addresses are all over the place, so there's a lot of cleaning up of those addresses that happen so that when we do the linking of these accounts, it can be done most efficiently. Moving into the entity resolution, we go through candidate generation. So think about billions of entities that are there in the graph, and we want to start with a small subset of accounts which we think are probable match. So that is what is called blocking or candidate generation. We do that. So for an incoming account ID, if there is an update on an email ID, we look into the graph that what are the different accounts which have the same email IDs. So imagine with spanner graph and having a graph database, what would have been billions of comparisons is now just those subsets of graphs that we've been able to pull in and get the account IDs for. Matching, this is where we actually get what are the accounts that are matching and belong to the same entity. We have rules for customer entity matchings, and rules are such that you want to have an exact match for email ID, but the name could be like a fuzzy match. So Alex and Alexander, we still want to be able to link them if they have the same email ID. As this happens, we also, in this phase itself, we do the explainability. We know the rules that are matched, so we bring in why they are matching in this phase itself. So we have the subgraphs, we have why they are linked, and we get into the clustering phase. This is where we take in all of those subsets of graphs and run the connected component algorithms, pull it all together, and we get that unified cluster. We also have the golden record creation, because if you have like 20 different accounts, we still want to be able to see what is your best view of that customer. And that happens here. Here we reconcile customer attributes, weighing recency along with quality and completeness of these attributes. And at each of these steps, it's going to the graph, pulling it, and it makes it so much faster than doing millions of joins that we would need to do in the other case, and that would make it all happen batch, and this can happen in real time. Serving of it can happen to agents, to mobile applications, or web, wherever we want it to be. And Spanner's strong consistency guarantees that you never get a stale identity update. Now, just going one level deeper to what's happening underneath with the billions of nodes and edges, right? And how does this actually happen? So it starts with the foundation that Spanner gives us, right? High availability, globally strong consistency. With true time, multi-region replication, automatic failover, we already have a good head start, and we don't have to worry about that side. When it came to loading the graph for us, it was humongous. I'll talk about the scale, but what we did, we designed a batch process that did the linking of the graph, and which was a Spark job running on a Dataproc cluster, and then we used reverse ETL to load that from BigQuery to Spanner Graph. So that was easy and also the most efficient for it. Coming to the data layout for the graph, this took us some time because this always has to be optimized for your access patterns that you have. So we looked at what were our access patterns now, and also some that we anticipated to come. And with interleaving, co-location, having a lean index design, we were able to do that fairly quickly. And again, back to the distributed read and graph traversal, having the graph made it happen very, very efficiently. So for our first phase, we are at 20 terabytes of data, 15 node cluster, 10 billion nodes, 20 billion edges, with graph reads at 50 milliseconds at P99. Now, and we are just getting started. A whole new set of use cases lined up as soon as we went out live with the first one. So all in all, consistency at base and parallelism at the top. That was the power that we were able to get from this graph architecture. Now, I don't want to make it sound that the journey did not have challenges, because we had quite a few. What is notable, though, that the speed in which we could build all of this together. Entity resolution has its own complexity, as you see with the multiple phases. Then getting that and the evaluation metrics, standing up the infrastructure, all we were able to do in 3 months. Definitely combination of a rockstar team, leveraging AI at every step of the way, and then also getting a lot of the features that I talked about from Spanner Graph out of the box. Okay, so the operational benefits that we got, we have a unified serving layer. We have the graph that can now get to multiple use cases of personalization, ads targeting, risk, and fraud applications. It's reusable across PayPal. We get the consistency and correctness. We have the scale and performance with Spanner. With billions of nodes and relationships, we achieve low latency reads and real-time traversal at scale. And then the managed infrastructure with Spanner. And so we don't have to operate or manage these graph clusters. We can focus on the engineering, do some design for the databases, and then here we go. I know we are at time. I'm just going to quickly wrap up here. Graph intelligence, when we think about it, we see it evolve around these few dimensions. Graph become the AI context layer. They provide a shared structured understanding of the entities and relationships. On one hand, they can be enriched with all of the AI that we want, and on the other hand, they can ground us with data, facts, governance, metadata, policies. And Graph shines for real-time intelligence use cases, as I talked about. This also enables connected reasoning. You can all put it together in real time and make so much more, get so much more insights out of it than you would be able to do if all of this was offline. And finally, it unlocks graph algorithms at scale. We did connected components, but now we are planning for more advanced algorithm that can help us towards personalization and customized experiences. So together, this represents a shift from the fragmented data and static systems to unified real-time intelligence that is governed and that powers AI-first experiences all across. Thank you so much. I'll call in Mukund. I tried to rush Mukund, but
Awesome. Thank you, Deepika. Thanks, Kiran. A pleasure to be here with all of you today. I know I'm standing in between your lunch and probably your flights back, but we'll make this quick. I am Mukund Gopalan, Chief Data Officer for Ingram Micro, and let's get this going. All right. Awesome. How many of you have heard about Ingram Micro or familiar with Ingram Micro? Just a quicker show of hands. Very nice, a few of them. We are the business behind the business. So if you have an iPhone in your hand, if you have a laptop, your Microsoft 360 or your Google G Suite, chances are that it's been sold through Ingram Micro at some point in time. So we are a very large B2B player here, and we support a lot of different partners. And it's very interesting because we may we are resellers for Google, we are also customers for Google. So either you have devices that have come through Ingram Micro, or your company is our customer, or we are selling to you. So either ways. 45 years in business, 1,500 vendors, everybody from Google to Apple to Microsoft are all our vendors here. Customers, we are a B2B company. We are not a B2C. So we sell to major resellers, VARs, MSPs, system integrators. That's our customer base, and we reach out a very large number of end users. Millions of customers are impacted through us. So that's just to give you an idea about the problem and the scale and what we're looking for. And a very large business, $52 billion, this is just net revenue. The gross is much higher. 57 countries, very global. 131 logistics centers, and more than 23,000, 24,000 associates. And so what was our challenge when we started out? We wanted to reimagine this entire business. We started this about 4 years back, and we wanted to completely reimagine what we are doing. And we wanted to build out an entire platform. Our platform is called Xvantage. And what was our starting point? We had a plethora of multi-generational legacy systems, everything from IBM mainframes to SAP ERP systems, and everything in between. And we are looking at these very large, complex, very siloed architecture, many different data silos across the organization, many different data warehouses. And we are looking at how do we make this an AI-first application, how do we make this a data-first application, and that was our starting point. And this is where we are today with some of the agents that we have listed on the bottom in production at this point. So our intelligent digital assistant is in production, serving billions of dollars of incremental revenue for our organization. We got a sales brief agent in production. So a lot of our agentic systems, including our email to order, that's our ETO, and insights and recommendations for customers. This is just a few of the examples where we have gone live today. So this is a big, big shift for our business, completely reimagined. All right, we'll get into our Xvantage, our AI-first data platform. We started this journey about 4.5 years back, and we're looking at how do we transform this entire industry. And if you look at the stats on the bottom, these are some of the numbers we're looking at. 120 million messages a day, transactional messages, all of them requiring very high levels of atomic integrity and asset properties. Very low latencies, because we are looking at customer transactions going across the globe, 50 milliseconds. Very high availability, because you're looking at an entire global operations, 24/7, some countries always live. And so this is our requirement. This is our very simplified architecture of what we have done here on our platform. And if you look at it, we needed a very, very robust database platform to be the foundation for this AI-driven system. And we needed this to be AI-enabled and very integrated to all of the AI systems that we wanted to deploy. And this was really our foundational piece. And that's why we chose LIDB, and I'll talk more about it in the next one. Awesome. So here's where we are, LIDB. And this is where our architecture starts coming to life. We have numerous ERP systems, like I talked about, all of them feeding messages in real time into our GKE clusters that process these messages and move them into our LIDB and make them available to all of our AI systems that run our applications. And with LIDB, what do we get with LIDB? Of course, it's an open source relational technology, so you don't have a lot of lock-in or vendor lock-in. The schema designs, the SQLs, everything is what people are familiar with. Easy training for all our thousands of engineers, our data scientists, and our analyst community. That's a much more easier launch for them. But in addition to that, you get all of these vector embedding, which is a very, very powerful feature that we are using quite a bit. The entire vector search, vector embedding, full text search, lots of capabilities that are unlocking features for our customers at scale. And at the same time, I talked to you the previous slide about operational requirements. We needed very high availability. And so this is where LIDB started giving us the good, because you always have a trade-off, functionality versus your operational. And that's where the LIDB has hit a very sweet spot for us with the functionality and the operational coming together. And you have very low read latencies. You have your read pools that can be spun up and down, load balanced. You have your compute and storage completely separated out, so you can scale each one of them. And you're not limited by any of the other limitations that you have with a Cloud SQL. And it's really a generational leap for us from Cloud SQL, both in terms of performance, in terms of availability, and in terms of the features that it can provide us. So this is kind of a summary for us. I know I've been super fast, but hopefully covered all of that. Thank you.
Thank you, Mukund. And you can hear great stories, two big stories from our customers, PayPal and Ingram Micro, talking about how they went about choosing a database for their workload. Quick, I know we have 1 minute to go. Quick, what are the key takeaways? A database for agentic AI. Our Google Cloud databases, our portfolio is now fully optimized to power your agentic initiatives, like we saw in a story from our presenters. How do you get started? We have free trials. We have Cloud SQL, LIDB, Spanner, and at this next, we also launched free trial for Bigtable. So you can take it for the spin and see where it goes. Second point is using an onboarding agent, as I showed you. Simplify your search for operational database for any workload. Use our operational onboarding agent and share your experience with us, please. Third is convergence. This is very critical. OLAP and OLTP coming together. The agentic data cloud is here now to make it happen for you, converging the operational and analytical data. Real-time data access, no matter where the data lives now. And that is the need of the business. And we hear from Ingram's story there, LIDB and BigQuery coming together. Same for PayPal. So those are the real-time examples here. With that, the learning continues. There are 2 sessions coming up. If you're still, if you're interested in database topics, there is one for Oracle and one for Spanner session. Please go and visit them. If you have a next app, please give us a feedback on this session today, how you felt and how you get useful there. And again, thanks for coming in for this session, everyone, and attending this. If you have any questions for me or my presenters here, I'll be standing down at the stage here. Please come through, or any more guidance you need. Thank you very much.